Welcome, friends to Science to Sleep By. Tonight, let's drift together into the vast, calming expanse of the cosmos. As you rest, your thoughts may wander into the quiet mysteries of the universe. One of those mysteries is both close to home and unimaginably far in the future, the question of what happens when the sun, our life-giving star, eventually dies. Don't worry, that day is not near. But tonight, we'll let its distant story unfold gently, like a lullaby written in starlight. Breathe deeply, let your body sink into calm. And let's take this journey together, exploring the serene science of what becomes of our sun. When we look up at the sky each morning, it might be easy to take the sun for granted. It has always been there, rising above the horizon, flooding the earth with light, and setting gently to welcome the evening. Yet behind its familiar glow lies an astonishing story of physics, chemistry, and cosmic balance. The sun, at this very moment, is a middle-aged star, a cosmic furnace that has been burning steadily for about 4.6 billion years. To understand what happens when the sun dies, we must first understand what it is right now in its current form, and how it manages to hold together the delicate web of life on Earth. Imagine, as you close your eyes, the warmth you feel on your skin when sunlight touches it. That warmth has traveled almost 93 million miles, racing across space in just over 8 minutes. And every beam carries within it the memory of nuclear reactions happening deep in the sun's heart. At its core, the sun is not a ball of fire, as ancient myths once described, but rather a sphere of plasma. A seething state of matter where gas is so hot that its atoms break apart into nuclei and electrons. In this furnace-like center, temperatures soar to around 27 million degrees Fahrenheit. Here, the pressure is unimaginably intense, so much so that hydrogen nuclei protons are forced together, fusing into helium. This process, known as nuclear fusion, what gives the sun its brilliance. Each second, the sun converts nearly 600 million tons of hydrogen into helium, releasing energy as light and heat. This energy pushes outward, balancing the inward pull of gravity. Without this delicate equilibrium, the sun would either collapse under its own weight or expand uncontrollably. Instead, it rests in a steady state, glowing steadily, nurturing Earth with its radiant energy. The sun's light sustains life in ways both obvious and hidden. Plants absorb it through photosynthesis, transforming light into chemical energy that becomes the foundation of nearly every food chain on Earth. Warmth from the sun maintains Earth's climate within a range that allows oceans to remain liquid and air to remain breathable. Even human biology is linked to its rays, as our bodies synthesize vitamin D with the help of sunlight. Every heartbeat, every breath, every meal we eat, is tied whether directly or indirectly to the steady glow of our sun. Without it, our world would be an unrecognizable frozen rock adrift in darkness. Yet, for all the comfort it gives, the sun is far from calm. Beneath its surface, churning currents of plasma move in vast loops, carrying energy outward. This motion generates magnetic fields which twist and snap, creating sunspots, solar flares, and streams of charged particles called the solar wind. These events remind us that the sun is alive with activity, a dynamic star with storms and tempests far larger than anything on Earth. Solar flares can unleash as much energy as billions of nuclear bombs, sending waves of radiation hurtling into space. The solar wind flows constantly, shaping Earth's magnetosphere, creating shimmering auroras in the polar skies, and sometimes disrupting satellites and power grids. While it looks serene from Earth, the sun is in truth a restless and powerful star, endlessly in motion. From our perspective on Earth, it feels eternal. Civilizations throughout history have worshipped it, woven it into myth, and marked time by its rising and setting. Ancient Egyptians saw it as the god Ra, crossing the sky in a golden chariot. The Greeks imagined Helios, steering his fiery horses from dawn to dusk. Even now, though we understand it as a star governed by natural laws, we still feel something primal when we watch a sunrise or sunset. The sight stirs both on comfort, reminding us of the sun's role as the anchor of our days and the silent guardian of our survival. But while the sun may seem changeless to us, it is constantly evolving. Deep inside, it is slowly but steadily transforming hydrogen into helium, altering its internal balance. Over billions of years, this process changes the sun's brightness and size. Right now, it is in what astronomers call the main sequence phase of its life, the long, stable period when stars spend the majority of their existence fusing hydrogen into helium. In this stage, the sun shines with reliable consistency, providing Earth with a stable climate. But even during this tranquil chapter, the sun has been slowly growing brighter. When life first appeared on Earth, the sun was dimmer and the planet cooler. Today, it is about 30% more luminous than it was in those ancient times. In the far future, this brightening will continue, gradually warming Earth in ways that will make our planet less hospitable long before the sun reaches its final stages. The sheer scale of the sun is humbling to consider. It makes up more than 99.8% of the total mass of the solar system. More than 1 million Earths could fit inside it. Its gravity holds the planets in their orbits, guiding the dance of worlds, moons, and asteroids across billions of miles. Every comet's path, every planet's season, every ripple of dust and gas that drifts near is influenced by the sun's immense presence. Without its gravity, the planets would scatter into the void, wander aimlessly through interstellar space. The sun's reach defines the solar system itself, its warmth marking the boundaries where planets can retain liquid water, and its light setting the rhythm for the cycles of life. And yet, for all its grandeur, the sun is only one among hundreds of billions of stars in the Milky Way galaxy. It is classified as a G-type main sequence star, yellow dwarf. Compared to giants and supergiants scattered across the galaxy, it is modest in size and brightness. Some stars burn more than 1,000 times brighter, while others are smaller and dimmer, glowing faintly in the dark. Still, for us, it is the most important star of all, errant star, the one that made life possible. The carbon in your body, the oxygen you breathe, even the calcium in your bones, these elements were forged in stars like the sun's ancestors, scattered across the galaxy, and now carried forward by the sun into the story of life. This moment in cosmic time. The sun is steady, dependable, and vital. It wakes us each morning, warms our days, and sustains the fragile ecosystems of Earth. But this chapter will not last forever. Like all stars, the sun is bound by the laws of physics to follow a path from birth to eventual death. What we see today is just one moment in a far greater journey that stretches across billions of years. For now, it continues to burn quietly, a cosmic companion to our existence, a reminder of both stability and impermanence. When we think about time, we usually measure it in hours, days, or years. Our lives span decades, perhaps a century, if fortune allows. Human history stretches back thousands of years, and recorded civilization reaches only a small fraction of that. Yet, in the cosmic theater, these numbers barely register. Stars, like the sun, live on timescales so vast that the rise and fall of empires, the shaping of continents, and the entire sweep of human culture unfold in the blink of a stellar eye. To appreciate the story of what happens when the sun dies, we must understand its lifespan in the context of the universe. This requires us to shift our perspective, to step away from human time and into cosmic time, where billions of years are the rhythm of creation and decay. Our sun is what astronomers call a main sequence star, and this phase of life defines the majority of a star's existence. It is here that hydrogen fusion takes place in a stable, balanced way, providing steady energy and light. The total main sequence lifespan of a star depends primarily on its mass. Stars far larger than the sun burn through their fuel at a ferocious pace, living brilliant but short lives, sometimes only a few million years. Smaller stars, such as red dwarfs, sip their fuel slowly, glowing dimly but enduring for trillions of years, outlasting almost every other structure in the cosmos. The sun, by comparison, sits in the middle ground. With its mass, it is expected to live for roughly 10 billion years in total as a main sequence star. Right now, the Sun is about 4.6 billion years into that journey, meaning it is nearly halfway through its stable phase. Imagine a long day, stretching from sunrise to sunset. If we place the Sun's life on that scale, then the dawn was its birth in a swirling cloud of gas and dust, when gravity gathered the material of a stellar nursery into a glowing ball of plasma. The morning hours were spent igniting nuclear fusion, pushing back against collapse, and finding equilibrium. The Sun today is around midday, shining strongly, at the height of its vitality. Noon has passed, but there are still long hours ahead before the twilight begins. This metaphor helps us to see the difference between human and stellar timescales. Our species, our civilizations, even our planet's current climate, all of these are fleeting moments compared to the billions of years that the Sun has already endured and will continue to endure. When we look at cosmic time, the Sun's 10 billion year lifespan is both enormous and modest. It is enormous because nothing in human history compares. The oldest human-made structures are mere thousands of years old. The entire history of Homo sapiens is measured in a few 100,000 years. Even the age of Earth itself, at 4.5 billion years, only just matches the Sun's current age. But the Sun's lifespan is also modest when set against the age of the universe. The cosmos itself is 13.8 billion years old. This means the Sun is a latecomer, born in a galaxy already rich with stars, planets, and heavy elements forged by earlier generations of suns that lived and died before it. Thinking about the Sun's place in cosmic chronology also reveals something profound. Stars are not eternal, but they are patient. They live at a tempo that is slow and steady, dictated by the balance of mass and fuel. The Sun consumes 4 million tons of hydrogen every second, and yet, it has taken billions of years for it to reach only the halfway mark of its life. For us, a second or a minute feels brief. For the Sun, a million years is barely a step. It is as though the Sun inhales and exhales across millennia, keeping time with the slow heartbeat of the galaxy. This lifespan also determines the fate of the solar system. Earth's history has been written under the stable light of the Sun's main sequence. From the earliest microbial life in ancient oceans to the dinosaurs that roamed lush forests, from the rise of mammals to the age of humanity, all of it has taken place under the same steady glow. But the stability is not permanent. As the Sun continues to age, subtle but significant changes occur. Its core gradually fills with helium, the byproduct of fusion, and as the balance shifts, the rate of fusion increases slightly. This leads to a slow brightening of the Sun over time. A billion years from now, Earth's climate may be dramatically hotter, oceans may begin to evaporate, and the biosphere as we know it could collapse long before the Sun reaches its true old age. The star's lifespan is therefore not just a timeline of its own existence, but the clock by which planetary environments are set. To place this into perspective, imagine if we could accelerate time and watch the Sun's entire life unfold like a movie. In the beginning, a swirling nebula collapses into a glowing orb, bursting with energy. For billions of years, it shines steadily, a golden anchor for its family of planets. Halfway through the film, we arrive at now Earth alive with oceans and forests, humans gazing up at the sky, wondering about their star. But as the film continues, the Sun grows brighter, hotter, and eventually begins to transform into something unrecognizable, a red giant, filling the screen with fiery expansion. Its lifespan ends not with a bang, but with a gentle fading, a glowing ember cooling slowly in the dark. What we are living through today is the middle chapter of this movie, one that feels eternal to us, but is only a heartbeat in stellar time. The Sun's lifespan also ties us to the broader life cycle of the universe. Stars are born, they live, and they die, just as living beings do. The difference is only in scale. Where our lives are measured in decades, theirs are measured in billions of years. Where we pass on knowledge, stories, and genes, stars pass on the very elements of existence: carbon, oxygen, iron scattered into space to seed new stars and new planets. The sun will never explode as a supernova, since it lacks the mass for such a fate, but even in its gentler death, it will return material to the galaxy. The atoms in our bodies, forged in earlier generations of stars, will one day be joined by the atoms that once made up Earth and the sun itself. In this way, the sun's lifespan is part of a larger rhythm, the pulse of the cosmos itself. For us in the present, though, it is comforting to realize that the sun's remaining lifespan still stretches across billions of years. Humanity may worry about climate, technology, or the survival of civilization in the coming centuries, but the sun itself will continue to shine long beyond those concerns. Its clock ticks slowly, indifferent to human drama, offering us time and stability to find our place in the cosmos. It is both a reminder of our fragility and our resilience, because while our lives are brief, we are connected to something enduring, something that bridges the gap between the fleeting and the eternal. Right now, the sun seems eternal to us. It rises each day, blazing with the same golden brilliance it has shone for all of human history. To our eyes, it doesn't change. Yet, on the scale of billions of years, the sun is quietly evolving, shifting in ways too slow for us to notice within a lifetime or even across civilizations. The transformation that lies ahead is subtle at first, like the faint stirring of a tide long before the waves arrive at the shore. This phase of change, when the sun slowly begins to alter as its fuel supply dwindles, is one of the most delicate and fascinating parts of a star's life story. To understand what happens when the sun dies, we must sit with the calm inevitability of its slow dimming, and recognize that even stars must yield to time. The sun, like all stars, is powered by nuclear fusion. Deep in its core, hydrogen is converted into helium, a process that releases energy in the form of light and heat. This balance of forces, gravity pulling inward, fusion pushing outward, is what makes the sun stable. But fusion cannot go on forever. The reservoir of hydrogen in the core is finite, and though it is immense, it is not infinite. As the sun steadily fuses hydrogen, helium begins to accumulate in its core. Unlike hydrogen, helium does not fuse under the same conditions, and it gradually builds up, creating a dense, inert center. Over time, this changes the way the sun behaves. The helium-rich core contracts under gravity, squeezing tighter and growing hotter. As it does, the surrounding shell of hydrogen just outside the core begins to fuse faster. This increased rate of fusion generates more energy, which in turn makes the sun grow brighter and larger. To us, here on Earth, the change is imperceptible in the short term. 100 human generations might pass with the sun appearing unchanged. Yet, across hundreds of millions of years, the increase becomes significant. Scientists estimate that in about 1 billion years, the sun will be about 10% brighter than it is today. That small percentage may not sound like much, but it will transform Earth's climate. The oceans, which now shimmer blue and calm under the sun's steady light, will begin to evaporate more quickly. The delicate balance of ecosystems will be disrupted. Eventually, Earth may grow too hot to sustain the kind of life we know now, long before the sun reaches the final stages of its life. This is the paradox of the sun's slow dimming. From one perspective, the sun is indeed dimming, for as it marches toward the end of its life, its time as a stable main sequence star is drawing to a close. Its supply of usable fuel is dwindling, and its balance is shifting. But at the same time, its outward brightness will actually increase, because the processes inside the star are accelerating as its fuel runs out. To describe it as dimming is to capture the inevitability of its decline, even as it grows more luminous in its aging years. The brilliance we see is, in a way, the final flourish before the star begins its long fade. When we think of the sun changing, we might imagine something sudden, a dramatic shift in the sky. But the truth is far gentler, unfolding with extraordinary slowness. If we could watch the sun's life in fast motion, speeding billions of years into a few moments, we would see it swell, shine brighter, and shift in color. But in real time, the change is so gradual that Earth itself will alter dramatically before our star appears visibly different. Continents will drift, mountains will rise and erode, species will evolve and vanish, civilizations may flourish and fall, all while the sun quietly grows hotter and brighter with each passing eon. The stillness of the sky hides a secret that the star we rely on is aging, inching ever closer to transformation. Inside the sun, the changes are profound, even if they remain invisible to us. The balance of pressure and gravity becomes increasingly delicate. Each moment of fusion is a negotiation between collapse and expansion, between order and chaos. As the helium builds up, the sun's core grows more compressed, hotter, and unstable. The hydrogen shell burns with greater urgency, like a candle flickering as the wax runs low. This flickering is not literal, yet it will come much later, but the seeds of instability are already being sown. The sun's future as a red giant, when it swells to engulf its inner planets, is set in motion by the quiet buildup of helium in its heart. The slow dimming of a star also serves as a reminder that change is not always visible, but it is always present. From Earth, we see constancy, but the sun is never still. It is a river of plasma, a sea of magnetic storms, a furnace of endless reactions. It is in constant motion, its surface boiling with convection, its atmosphere sending winds across the solar system. The idea that this dynamo of energy could one day falter, could one day enter its twilight, is almost beyond comprehension, yet it is the reality of all stars. Just as we measure our lives in childhood, adulthood, and old age, so too do stars pass through stages, each defined by the way they burn their fuel. The sun is simply living out its natural course, though on a stage so vast that we struggle to see the play unfold. The scientific understanding of these processes has given us a kind of foresight. Ancient peoples saw the sun as unchanging, a divine fire that would shine forever. Today, we know that it has a history and a future. By studying other stars at different points in their life cycles, astronomers can glimpse the future of our sun. They see young stars still forming in nebulae, blazing hot stars near the end of their lives, and the glowing remnants of stars that have already passed into white dwarfs. Each one is a mirror reflecting a piece of the sun's journey. From these observations, we learn that the slow dimming is not an end, but a transition, part of a pattern written across the galaxy. For us on Earth, the timescales are so vast that the sun's evolution feels more like poetry than threat. 1 billion years is long enough that humanity as we know it may be unrecognizable, or even absent by the time Earth feels the full force of the sun's changes. Yet the thought carries weight, reminding us of our smallness in the face of cosmic time. The sun's slow dimming is both a scientific reality and a philosophical meditation. It shows us that permanence is an illusion, that even the brightest stars must yield to the passage of time, and yet, there is comfort in the slowness. Unlike massive stars that burn violently and end in catastrophic supernova explosions, the sun moves toward its future with patience and grace. Its decline is measured not in centuries, but in billions of years. There is no sudden darkness awaiting us, no abrupt snuffing out of light. Instead, there is a gradual unfolding, a star slowly shifting into its next phase, offering the solar system plenty of time to adapt, evolve, and perhaps even relocate. In its slow dimming, the sun gives us time, not endless time, but time enough to grow, to imagine, and to seek our future among the stars. As the sun continues along its long path through time, it will eventually reach a moment when the balance that has kept it steady for billions of years can no longer hold. This is the turning point, the moment when the slow and almost invisible changes deep in its core give rise to a transformation so dramatic that it will remake the solar system itself. The sun, now calm and golden, will one day swell into a red giant, a swollen, glowing star far larger and brighter than it is today. This phase will not come for billions of years, but when it arrives, it will mark one of the most breathtaking and destructive spectacles in the history of our solar system. To imagine it is to step into a vision of the far future, a time when our familiar sun becomes almost unrecognizable. The story begins with the exhaustion of hydrogen in the sun's core. For billions of years, hydrogen fusion has generated the energy that sustains the sun, balancing the inward pull of gravity. But once the core is filled mostly with helium, fusion there comes to a halt. Without the energy of fusion pushing outward, gravity takes over, compressing the core tighter and tighter. As the core contracts, it grows even hotter, reaching temperatures far beyond what they are today. Around this contracting helium center, a shell of hydrogen continues to fuse, and it is this shell that becomes the new source of energy. The increased energy output from this shell causes the sun's outer layers to expand outward, growing larger and cooler in surface temperature. This is what transforms the sun into a red giant, not a fading star, but one that grows swollen and luminous, glowing red-orange in the vastness of space. From Earth's perspective, if Earth still remains habitable long enough to witness it, the sun's expansion will be both beautiful and terrifying. Over the course of hundreds of millions of years, its size will increase until it engulfs the orbits of Mercury and Venus. The sun, once a gentle disk in the sky, will fill the heavens with its swollen body. It may grow up to 200 times its current size, a bloated star whose radius stretches far into the solar system. To imagine this is to imagine the sky transformed into fire. From a planet's surface, the sun's red light would dominate every horizon, its heat searing, its presence overwhelming. For Earth, this change spells the end of familiar conditions. Long before the sun reaches its greatest size, the heat will become unbearable. Oceans will boil away, their waters lost into space. The atmosphere will be stripped, leaving a barren, scorched surface. Rocks will glow with heat, and the planet that once teemed with forests, rivers, and civilizations will become a lifeless desert. Whether Earth itself will be physically engulfed by the expanding sun is still debated among scientists. Some models suggest the sun's expansion will reach Earth's orbit, swallowing the planet completely. Others suggest that while the sun grows outward, it will also lose mass through powerful stellar winds, causing Earth's orbit to drift farther away, perhaps just enough to escape total engulfment. In either case, Earth as we know it will be unrecognizable, either consumed in the sun's fiery body or left as a dead, charred husk circling a dying star. Yet in this destruction, there is also grandeur. A red giant is a spectacular sight, a star blazing with intensity at the twilight of its life. Its outer layers, now cooler than before, radiate in shades of orange and red, while its core burns hotter than ever. For distant observers, perhaps future civilizations on other worlds, the transformation of our sun into a red giant will be a reminder of the cosmic cycle of birth, growth, and decay. The light of a red giant is softer in color, but its brightness is far greater than the sun we know today. For planets farther out, Mars, the moons of Jupiter, even the icy worlds beyond, this sudden increase in light and warmth may briefly transform them into places of new activity. Ice could melt, frozen surfaces could awaken, and worlds that have slept in cold darkness might briefly feel the touch of liquid water and energy. The transformation into a red giant is not gentle for the star itself. The sun will lose vast amounts of its material during this stage. Its outer layers, expanded and unstable, will be blown away by strong stellar winds. Streams of gas will flow outward into space, forming halos of material that stretch across millions of miles. These winds will strip away nearly half the sun's mass, sending it drifting into the solar system. This shedding of layers is what sets the stage for the next chapter of the sun's life, when its core is revealed as a white dwarf and the surrounding gas becomes a glowing nebula. But during the red giant stage, the process will be chaotic and spectacular, a storm of matter and energy reshaping the space around it. For the solar system's planets, the consequences will be dramatic. Mercury and Venus will certainly be destroyed, engulfed by the expanding star. Earth, whether consumed or left behind as a scorched ruin, will no longer be habitable. Mars may briefly warm, its frozen ground releasing gases, its surface transformed by the temporary surge of sunlight. The outer planets will also feel the change, though less directly. The balance of orbits may shift as the sun loses mass, causing planets and moons to drift into wider paths. Comets, asteroids, and icy bodies in the Kuiper belt will be disturbed by the new gravitational order, scattering through the solar system in chaotic ways. The sun, once the stable anchor of the planetary dance, will become unstable, altering the choreography of its celestial family. To visualize the sun as a red giant is to see both power and fragility. Its expansion is driven by immense forces, the heat of fusion and the collapse of gravity, yet it is also the sign of a star in decline, struggling to find balance as its fuel runs out. The red glow that will one day dominate the solar system is not a sign of youth or vigor, but of age and impending death. Stars like the sun do not go quietly, but neither do they explode violently like supernova. Instead, they swell, lose themselves in vast outpourings of gas, and gradually release their outer beauty into the cosmos. For humanity, imagining the sun as a red giant is both unsettling and humbling. It is a reminder that the world we know is temporary, that even the star we depend upon has a lifespan and an end. But it also connects us to a broader truth, that change is universal, and that endings in the cosmos are not final, but transformative. The sun's red giant phase is not the collapse of everything, but the transition to something new. The elements cast off during this time will drift through the galaxy, carrying with them the seeds of future stars and planets. The story of the sun's death will become part of the story of countless other worlds yet to form. When we think of the sun's distant transformation into a red giant, the question that naturally arises is, what will happen to the Earth? This pale blue dot, our fragile home in the vastness of space, has always depended on the sun's steady warmth and light. The cycles of day and night, the changing of the seasons, the growth of forests, the rise of civilizations, all of these have unfolded under the sun's watchful glow. But as the sun evolves, swelling and brightening in its old age, Earth's story will be profoundly altered. The fate of our planet is written in the physics of the star it orbits, and while the timeline stretches into the billions of years, the outcome is certain. Earth will not escape untouched. The process begins long before the sun reaches its final red giant phase. Even while it is still on the main sequence, the gradual brightening of the sun will have serious effects on Earth's climate. A billion years from now, the sun's energy output will be about 10% higher than it is today. That may not sound catastrophic, but such an increase will tip Earth's delicate balance. Temperatures will rise, and the oceans, which regulate climate and sustain life, will begin to evaporate. Water vapor, a powerful greenhouse gas, will build up in the atmosphere, trapping even more heat. A runaway greenhouse effect will take hold, much like what we see on Venus today, where temperatures soar high enough to melt lead. As Earth's oceans boil away, the planet's surface will dry and crack, turning into a barren desert. Rivers and lakes will vanish, clouds will disappear, and the protective atmosphere that cushions us now will thin and dissipate. The biosphere, which has thrived for billions of years, will collapse. Life, if it still exists at that stage, will be forced into extreme niches, perhaps underground or in the high atmosphere, before eventually disappearing altogether. Earth, once a vibrant world of blue seas and green continents, will become a lifeless, scorched husk. This transformation will happen slowly on human timescales, but in the cosmic sense, it will be swift. A few 100 million years of transition compared to billions of years of stability. As the sun enters its red giant stage, the changes become even more dramatic. Its expansion will be relentless, and its swollen atmosphere will reach farther into the solar system. Mercury and Venus will be consumed outright, their orbits swallowed by the fiery body of the star. Earth stands on the edge of this fate. Some models predict that Earth too will be engulfed, pulled into the sun's outer layers where it will vaporize completely. In that case, the Earth's story ends in fire, consumed by the very star that once sustained it. Other models suggest a different outcome. As the sun loses mass during its red giant phase, its gravitational grip on the planets will weaken. Earth's orbit could drift outward just enough to escape being physically swallowed. Yet even if the planet survives as an object, it will be utterly unrecognizable. Its surface will be molten, its atmosphere gone, its oceans long vanished. Whether Earth is consumed or left behind as a charred rock, the conditions that once allowed life will be destroyed beyond recovery. this stark future invites reflection on the fragility of habitability. Earth has not always been a gentle home. It has endured ice ages, asteroid impacts, mass extinctions, and dramatic shifts in climate. Yet through it all, the sun's stability has been the constant factor that allowed life to persist. The narrow band of distance from the sun where liquid water can exist, the so-called habitable zone, has shifted slowly over time, but Earth has remained within it. In the far future, however, the habitable zone will drift outward as the sun brightens. Mars, which is now cold and barren, might briefly fall within this life-friendly region, potentially thawing and becoming more temperate. Even the icy moons of Jupiter and Saturn, places like Europa or Enceladus, may warm enough to experience surface oceans. For Earth, though, this migration of the habitable zone spells doom. The planet will be left behind, stranded in a furnace that no longer supports liquid water, air, or life. There is also the matter of time. While Earth's complete destruction lies billions of years away, the slow changes leading up to that moment mean that its habitability has an expiration date. Some estimates suggest that Earth may only remain truly life-friendly for another 500 million to 1 billion years. After that, rising temperatures will trigger irreversible changes. From the perspective of human civilization, this timescale is unimaginably long, but from the perspective of evolution and the history of life, it is the blink of an eye. Life has flourished here for over 3.5 billion years. Another billion may be all that remains before the planet becomes inhospitable. For humanity, this distant forecast raises questions about survival and destiny. Long before Earth is destroyed or rendered uninhabitable, our species or its descendants will face the necessity of finding a new home. Whether through space travel, colonization of other planets, or the creation of artificial habitats, the long-term future of intelligent life lies beyond Earth. The fate of our world is tied to the fate of the sun, and while the sun's death will unfold too slowly for us to witness directly, the knowledge of what lies ahead shapes how we think about our place in the universe. In a broader sense, the fate of Earth underlines the impermanence of all worlds. Planets form, evolve, and eventually change beyond recognition. The Earth we know today is not the same as the Earth of the past, when continents were in different places and life forms were entirely different. An Earth of the far future will be stranger still, a barren desert, perhaps a molten rock, perhaps nothing more than dust swept away into space. Our home is temporary, a stage in a much larger story written by the cosmos, and yet, there is beauty in this impermanence. The destruction of Earth does not mean the end of everything. The materials that make up our planet, the carbon, oxygen, iron, silicon, will eventually be scattered back into the galaxy when the sun sheds its outer layers. These atoms may drift for millions of years before coming together again in new clouds of gas and dust. They may one day form new planets around new stars, perhaps even new worlds capable of supporting life. In this way, Earth's fate is not final but part of a cycle, a transformation from one form to another. The atoms in our bodies, which came from ancient stars, will eventually return to the stars again. For now, though, Earth remains vibrant. The sun still shines steadily, the oceans still shimmer, and life still thrives in endless diversity. The fate of the Earth lies billions of years in the future, far beyond the reach of our immediate concerns. But in contemplating that fate, we find perspective. We are reminded that our planet, precious and fragile, is a fleeting oasis in an ever-changing cosmos. Its time as a cradle for life is finite, and that makes the present all the more meaningful. We live in the middle chapters of Earth's story, a moment of balance between the past and the distant, fiery future, when the question arises of what happens when the sun dies. One of the most haunting and thought-provoking aspects is the fate of Earth itself. This tiny blue planet has been our cradle, our stage, and our sanctuary for billions of years. Every sunrise, every storm, every forest and ocean, and every civilization has existed under the steady glow of the sun. The bond between Earth and the sun is inseparable. Our planet's climate, its ecosystems, and even the chemistry of our very bodies are tied to the energy radiating from that star. But the sun is not eternal, and its inevitable changes will reshape Earth in ways that are almost unimaginable. Even before the sun swells into a red giant, its steady brightening will begin to destabilize Earth's fragile balance. The sun grows about 10% brighter every billion years, and this seemingly modest increase will have dramatic effects. Within about a billion years, Earth will already be well on its way to losing its habitability. More solar energy will heat the surface, triggering a runaway greenhouse effect. As the oceans begin to evaporate, water vapor will accumulate in the atmosphere. Water vapor itself is a greenhouse gas, meaning it traps heat, which accelerates the warming process. This creates a feedback loop that drives surface temperatures higher and higher. Our familiar world of oceans and continents will vanish. The seas will boil away, leaving behind vast, empty basins where waves once crashed. Clouds will disappear from the skies, no longer able to form without oceans to supply their vapor. Rain will cease to fall, and the planet will dry out into a barren wasteland. The rich, complex biosphere that has taken billions of years to evolve will collapse. Forests will wither, animals will vanish, and eventually even microbial life will fail as surface conditions grow too extreme for survival. If life does cling on, it may retreat into extreme environments underground or high in the atmosphere, but eventually, it too will fade. Earth will become as lifeless as Mars or Mercury, a sterile desert where no rivers flow and no leaves unfurl. This is only the beginning. When the sun leaves the main sequence and swells into a red giant, the changes become catastrophic. Its swollen outer layers will stretch far into the solar system. Mercury and Venus will almost certainly be engulfed completely, swallowed by the fiery atmosphere of the dying sun. Earth's fate, however, lies on the edge of uncertainty. Some models predict that Earth, too, will be consumed, vaporized in the expanding solar inferno. Others suggest that as the sun loses mass during its red giant phase, its weakened gravity may allow Earth to drift outward to a safer orbit. Yet this is not a true reprieve. Whether Earth is consumed or barely survives, it will not remain a home for life. The surface will be scorched and molten, the atmosphere stripped away, and the oceans long gone. Earth will be nothing more than a burnt-out rock circling a dying star. What makes this vision particularly striking is how it underscores the fragility of habitability. For over 4 billion years, Earth has managed to exist within the sun's habitable zone, the narrow range of distances where liquid water can persist. That delicate balance is what allowed life to take hold, evolve, and flourish. But the habitable zone is not fixed. As the sun grows brighter, the habitable zone will shift outward, away from Earth. Mars, currently frozen and inhospitable, might briefly thaw into a warmer, wetter world. Even the icy moons of the outer solar system Europa, Enceladus, Titan might warm enough to have liquid water on their surfaces. While Earth becomes uninhabitable, their worlds could enter a golden moment of possibility. Yet for our planet, that opportunity will have passed. This brings into focus a sobering reality. Earth has an expiration date. While the sun's final destruction of Earth may lie billions of years away, the gradual loss of habitability will arrive much sooner. In 500 million to 1 billion years, Earth's climate will already be too harsh to support complex life. From a human perspective, that timescale seems infinitely long, far beyond anything we need to worry about. But on evolutionary timescales, it is not so distant. Life has already existed on Earth for more than 3.5 billion years. Another billion could be the final chapter for this world as we know it. This cosmic forecast has profound implications for humanity. If intelligent life endures, our species, or whatever descendants may follow, will face the challenge of survival beyond Earth. To outlast the sun's changes, we will need to look outward, toward colonizing Mars, building habitats in orbit, or venturing to other star systems entirely. The end of Earth's habitability does not necessarily mean the end of humanity, but it does mean that our long-term survival depends on leaving the cradle. Earth has sheltered us, but it cannot be our eternal home. And yet, there is a kind of beauty in this fate. When the sun eventually sheds its outer layers and becomes a white dwarf, much of Earth's matter will be lost to fire or left behind as lifeless rock. But those same atoms that compose our mountains, oceans, forests, and even our own bodies will not disappear. They will be recycled into the cosmos, scattered across the galaxy to one day form new stars, new planets, and perhaps new life. Earth's destruction is not an ending, but a transformation, another chapter in the endless cycle of creation and renewal that defines the universe. For now, though, Earth thrives. The sun shines steadily, the oceans still cradle life, and the biosphere remains vibrant. Knowing Earth's eventual fate does not diminish its present beauty, it heightens it. Every sunrise, every breath, every moment of life is more precious when we understand that it cannot last forever. We are living in a fleeting but extraordinary moment in Earth's history, a golden era of habitability suspended between the chaos of the past and the fire of the distant future. Our planet's fate is written in the stars, but our appreciation of it is written in us. When the sun completes its red giant phase, swelling to a size so enormous that its outer layers will stretch far beyond its current radius, its next transformation begins. This is the stage that brings the sun into its final act of stellar existence, the white dwarf stage. Unlike the fiery intensity of the main sequence sun that nurtured life, or the monstrous expansion of the red giant that scorched the inner planets, the white dwarf is quiet, dim, and ghostly. Yet, in this quietness lies an extraordinary truth. The white dwarf represents both the survival and the end of the sun. To understand this final form, we need to trace how it emerges and what it means for the solar system. As the sun swells into a red giant, it will burn helium in its core after exhausting its hydrogen supply. This burning phase is violent, but short compared to the billions of years the sun spent fusing hydrogen. Helium fusion produces carbon and oxygen, the heavier building blocks that make up so much of the matter we are familiar with. But the sun is not massive enough to sustain fusion beyond this stage. Unlike stars many times its size, it cannot ignite carbon fusion and thus cannot become a supernova. Instead, after the red giant phase, the sun will shed its outer layers into space. This shedding is not a gentle release, it is a massive expulsion of gas and dust, flung outward into the solar system, forming a glowing shell of material illuminated by the remaining stellar core. This stage is what we call a planetary nebula. Though the name is misleading since it has nothing to do with planets, the planetary nebula marks the end of the sun's active life as a star. It is a beautiful farewell, a cosmic exhalation that spreads the elements forged inside the sun back into the galaxy. But what remains after this shedding is the true remnant of the sun, the white dwarf. The core, unable to continue fusion, collapses inward under its own gravity. What is left is a tiny, dense object, roughly the size of Earth, but with half the mass of the sun compressed into it. Imagine an object so dense that a teaspoon of its material would weigh several tons on Earth. This is the white dwarf stage, a stellar ember, glowing faintly not from fusion, but from residual heat. For billions of years afterward, the white dwarf will radiate away its stored energy, slowly cooling as time progresses. It will no longer produce energy through nuclear fusion, which is what defined it as a star. Instead, it will be a hot corpse, a relic of what once was. Its surface will shine with a pale light at first, brilliant enough to illuminate the planetary nebula around it, but over time it will fade. The planetary nebula will drift away, dispersing into interstellar space, leaving the white dwarf alone in the vastness of the cosmos. The white dwarf sun will be unlike anything familiar to us. Today, the sun is a vast, fiery sphere of plasma, dynamic and ever-changing, with sunspots, solar flares, and magnetic storms. The white dwarf, by contrast, will be static, silent, and unchanging, locked in the grip of quantum mechanics. The pressure that holds up a white dwarf against further collapse is not from heat or fusion, but from electron degeneracy pressure, a quantum effect that arises when electrons are packed so tightly they cannot be squeezed any closer. It is physics on the most fundamental level, ensuring the white dwarf remains stable against gravity even though no new energy is being generated inside. around this shrunken remnant. The solar system will be a very different place. The planets that survive the red giant phase will orbit a faint, cooling sun. Their paths will have shifted, as the sun will have lost a significant fraction of its mass during its transformation, causing their orbits to drift outward. Earth, if it still exists at this point and has not been consumed or incinerated during the red giant stage, will be a cold, barren rock orbiting a dim stellar ember. Mars may linger, distant and lifeless. The outer planets, like Jupiter and Saturn, will continue their slow revolutions, but their moons, once icy and frozen, will no longer have the faint hope of being warmed by a distant glow. The solar system will feel emptied, hollowed out, haunted by the ghost of the star that once revolved around. The white dwarf itself will persist for billions, even trillions, of years. Over time, it will cool further and fade to black, becoming what astronomers call a black dwarf, a theoretical object, since the universe is not yet old enough for any white dwarf to have cooled to that stage. A black dwarf would be completely dark, invisible, and inert, a final cosmic cinder. The sun, once the giver of life and light, will end as a cold, silent remnant, drifting forever through the galaxy. But even in this final stage, the sun leaves behind a legacy. The materials it shed during its planetary nebula phase, carbon, oxygen, nitrogen, will enrich the interstellar medium. These elements will mix with clouds of hydrogen gas scattered through the galaxy, seeding new generations of stars and planets. The very atoms that made up Earth, and even our own bodies, will return to the cosmic cycle, perhaps one day becoming part of new worlds, and maybe even new life. In this sense, the white dwarf stage is not just an ending, but a beginning for other stars, other systems, and other stories. It is humbling to think about the timescales involved. The sun has already existed for about 4.6 billion years, and it is expected to last another 5 billion before it becomes a red giant. The white dwarf phase will stretch for untold billions beyond that. The lifespan of the sun's remnant will outlast not only Earth, but even the galaxy as we know it. Long after the Milky Way has merged with Andromeda, long after new stars have formed and old ones have died, the sun's white dwarf will still be there, quietly cooling, a frozen memory of a once vibrant star. For us, contemplating the sun's white dwarf stage reveals the ultimate impermanence of even the most stable things we know. The sun, which rises every morning and feels eternal from a human perspective, is part of a cycle of birth, life, death, and transformation that all stars undergo. And yet, in its death, it also ensures continuity. Without dying stars, there would be no carbon for life, no oxygen to breathe, no silicon to build worlds, no iron to form cores of planets. The sun's future as a white dwarf is not merely the end of light for Earth, it is part of the larger story of how the universe recycles itself endlessly, giving rise to new beginnings from old endings. The sun's white dwarf stage may seem distant, almost unreal, because it unfolds on timescales so immense that they defy human imagination. But when we pause to reflect, there is comfort in this knowledge. We are part of a story that stretches beyond human lifetimes, beyond civilizations, beyond even the lifespan of Earth itself. The sun will die, but its remnants will continue to shape the universe long after we are gone. And in that quiet, enduring ember, the memory of the star that warmed our planet and nurtured our existence will live on. When we lift our eyes to the night sky, we are gazing into an ocean of light that has traveled across vast stretches of time and space to reach us. Each star we see is a story in progress, a living timeline of birth, life, and eventual death. The sun, though unique to us because of its central role in our existence, is not an exception to this cycle. It is one of countless stars scattered throughout the galaxy, bound by the same laws of physics, and destined to follow the same path of transformation. To consider what happens when the sun dies is to step back and place ourselves in the grander perspective of the cosmos, a perspective that is both humbling and awe-inspiring. From this wider view, the death of the sun is not a catastrophe, but part of the natural rhythm of the universe. Stars form from clouds of dust and gas, live for millions or billions of years depending on their mass, and eventually die, returning their materials to the galaxy. This process ensures that the universe is never static. It is in constant motion, always changing, always creating. The sun itself was born from such a cycle, about 4.6 billion years ago, from the remnants of older stars that had exploded long before. The very atoms that make up our body's carbon, oxygen, nitrogen, calcium, iron were all forged in ancient stars. In that sense, we are already participants in the cosmic cycle of life and death. When the sun becomes a white dwarf and eventually cools to invisibility, it will be adding its own story to that cycle. The materials shed during its red giant and planetary nebula phases will scatter outward into space. They may drift for millions of years, mixing with the interstellar medium until gravity pulls them into new clouds of star-forming gas. Eventually, they may help give birth to new stars, new solar systems, and new planets. Perhaps on one of those planets, under the warmth of another sun-like star, life will take root once again. In that distant future, the atoms that were once part of Earth, of trees, of oceans, of animals, and of us, may contribute to a new beginning. The universe, through its endless cycles, does not waste. It recycles and transforms. This perspective challenges our usual sense of permanence. From the human point of view, the sun feels eternal. It rises every morning without fail, provides warmth in summer, and sustains the rhythms of nature. Civilizations have built calendars and myths around it. To us, the sun is the great constant in the sky. And yet, when we expand our view to the cosmic scale, we see that it is temporary. It is a stage in a much longer story, one that began billions of years before us, and will continue for billions of years after. Understanding this truth places us in a position of humility. Our lives, our histories, our very species are brief sparks compared to the timescales of stars. But this humility does not diminish our significance, it enhances it. To recognize that we are conscious beings capable of contemplating the fate of the sun is extraordinary. We are, in a very real sense, the universe becoming aware of itself. The atoms that were forged in stars have combined in such a way that they can now look back, reflect, and wonder. We are part of the story, but we are also the narrators of it. The death of the sun may be inevitable, but the meaning we draw from it is something only we can create. The cosmic perspective also emphasizes resilience and continuity. Stars die, but their deaths sow the seeds for new creation. Galaxies collide, but from the chaos emerge new forms of order. The universe itself may one day evolve beyond its current state, but even then, the transformations will carry forward the materials and energies that exist today. There is a profound beauty in this cycle. A reassurance that nothing truly disappears, it only changes form. For humanity, this suggests that while Earth may one day be destroyed, the essence of it, the materials that compose it, will continue. In some distant corner of the galaxy, a future being might hold a fragment of matter that once belonged to our world. Thinking in these terms also allows us to appreciate the rarity of our moment. The sun is alive and steady. Earth is vibrant, full of oceans, forests, and life. We live at a time when the conditions are perfectly aligned to allow our existence. This is not an eternal state. It is a brief window in the history of the cosmos, one that will not last forever. But far from making our existence meaningless, this impermanence makes it precious. Just as we value a sunset because it fades, so too can we value life because it is fleeting. The knowledge that the sun will one day die reminds us to treasure the time we have beneath its light. The cosmic perspective also asks us to consider our future. Humanity has the unique ability to foresee the eventual uninhabitability of Earth. Long before the sun becomes a red giant, the planet will cease to support life as we know it. This knowledge gives us an extraordinary responsibility. Unlike other species, we can anticipate the end and prepare for it. Whether through space exploration, the colonization of other planets, or the creation of habitats beyond Earth, the survival of our descendants may depend on how we respond to this cosmic forecast. In this way, contemplating the death of the sun, not only an exercise in astronomy, but also in vision and foresight. It invites us to imagine what humanity could become if it chooses to endure, and yet, even if humanity does not endure forever, the universe will. Stars will continue to be born and to die. Galaxies will continue to evolve. The story of the cosmos will unfold regardless of whether we are there to witness it. This can feel daunting, but it can also be liberating. We are not responsible for holding up the universe. We are participants in its vast, ongoing narrative. What we can do is marvel at it, learn from it, and take comfort in the fact that we are part of something far larger than ourselves. In this perspective, the sun's death is not a tragedy, but a transformation. It is a reminder that endings are also beginnings, that destruction is also creation, and that every part of the universe is connected to every other. The sun's journey, from its birth in a cloud of gas to its eventual death as a white dwarf, is one chapter in a book that spans billions of years and countless stars. By reflecting on it, we gain not only knowledge, but also wisdom. We come to see that our lives, though brief, are woven into the fabric of something vast and enduring. To imagine the sun's final transformation is to accept the impermanence of all things while also recognizing the continuity that lies beneath change. The sun will die, earth will perish, but the universe will carry on, endlessly renewing itself. And we, for this brief moment in time, are here to witness it, to ponder it, and to find meaning in it. When we ask what happens when the sun dies, we are really asking about more than the fate of a single star. We are asking about the destiny of our planet, the fragility of life, and our place in the vast, unfolding story of the cosmos. The sun's journey from a brilliant main sequence star to a swollen red giant, and finally to a quiet white dwarf, is written in the physics of the universe. Earth, once vibrant with oceans and forests, will become uninhabitable long before the sun's final transformation, and eventually it will either be consumed or left behind as a lifeless rock. And yet, this story is not one of despair. The sun's death will scatter its elements into space, enriching the galaxy with the very materials that make life possible. Just as we are made from the ashes of ancient stars, future worlds, and perhaps future life, will be made from the remnants of the sun and earth. In this way, the end of the sun is not a final act, but a continuation of the cycle that has been at work since the beginning of time. For us, living in the present, this cosmic perspective is both humbling and empowering. It reminds us of the rarity and preciousness of our moment beneath the sun's light. It challenges us to care for our fragile world, to think beyond the short span of human history, and to consider the long arc of existence. The sun will not last forever, but the story it is part of will. And for now, while it still shines, we are here to witness it, to cherish it, and to carry its light within us as we dream of the future.